Okay, so now we're really getting into the most sophisticated questions for acid-based chemistry. And that is when we think about whether or not a particular reagent is suitable to protonate or deprotonate a particular reactant. In this case, I've got an alkoxide anion. And the question is water a suitable reagent to protonate the alkoxide anion? And so what we need to do is we need to write a reaction that actually represents that. So I'm going to let water be the other reactant, and I'm going to have it protonating the alkoxide to form an alcohol as the product. And then, of course, then the other product is OH ion. Now, we can't consider resonance or atom or orbital or any of that stuff because everything is equal in this case. So the atom is both oxygen. Those are the two negatively charged atoms. They're both sp3 hybridized orbitals. There's no resonance. There's no other atoms that are inductive. So what are we gonna think about here is whether or not we really have to lean on pKa's at this point. And so this is where those pKa's come in handy, right? The pKa of water is 15.7. The pKa of an alcohol is 16. So is water a suitable reagent to protonate the alkoxide? What we say is that the equilibrium favors the side of the reaction with the weaker acid on it. And the alcohol is technically the weaker acid. But it's not a whole lot weaker. It's 15.7 versus 16. So because pKa is a logarithmic scale, it turns out that this is about this side would be about 3 times larger than this side. If this was 1x over here, this would be 3x over there. So that's not particularly favorable. And so what I would say is the answer to the question is yes, but it's not great. There certainly would be better acids out there in order to protonate an alkoxide. So the basic answer to the question is yes. If you really get sophisticated, you'd say, but the favorability isn't that great. Yes, there'd be 3 times more products than there would be reactants. That's still not a particularly efficient reaction. We would probably look for something that's a little bit more efficient. So we might add a little HCl or something like that to make it happen. Okay.